you serious? Are you serious? Okay, guys.
The galactic core, center of the Milky Way, 26,000 years ago. And the Andromeda Galaxy, our next-door neighbor, 2.5 million years ago. But practically yesterday on a cosmic scale.
I love this cluster.
For almost 90% of the look-back time, the album is filled with common galaxies. Common, yes, but intriguingly diverse.
These two are colliding. You can see one going what appears to be right through the other. And there's a lot of drama in the way galaxies evolve and the way they interact with one another. So this one would be, it's only about 500 million light years away.
As Danley places each shot in the album, a bigger picture begins to emerge. Adult galaxies have been the main characters, evolving in all their variety for the past 12 billion years. But the cosmos also has its childhood photos, showing galaxies when the universe was a mere toddler.
These are actually very interesting galaxies at about 11 billion light years away. These compact galaxies represent what might be a two or 2.5-year-old child, just really learning how to walk.
But even these galaxies have their younger brothers and sisters. This spectacular shot shows a gravity lens, a cluster of galaxies 2.2 billion light years away that bends light, allowing us to see much further in space and time. The lens reveals a tiny speck identified as one of the earliest galaxies we can see, as it was 13 billion light years ago, still an infant in the evolving universe.
Galaxies, when they were babies, really don't have a lot of distinguishable features. They're kind of blobs. They don't really have a lot of structure.
The universe as a whole was something of a blob at the beginning of its life, too. What we see of that time are the first light waves in history, reaching us only now, 13.7 billion years after they flashed into existence. We see them in the picture of an afterglow from the Big Bang. And they are known today as the cosmic microwave background radiation.
The cosmic microwave background radiation is the most distant thing we can see. It is, in a sense, the picture of the baby upon delivery.
NASA's all-sky picture reveals a glow that is uniform everywhere we can see. The universe as it was in a cosmic moment after its birth. But here, our view comes to a sudden halt. What we can see of the universe is limited, not by the size or power of our instruments, but by the barrier of light speed itself. How can the fastest thing in the universe make us blind to the infinity of space? Knowing that light speed is 6 trillion miles per year gives us the light year, a convenient shorthand for talking about the huge distances in the universe. But it's just as important to understand that light speed at 6 trillion miles per year is an ironclad constant.
The speed of light is so constant that the universe actually changes everything so that you never see it going any other speed. So the speed of light really is the measuring stick of the entire universe.
In fact, the constancy of light speed results in an amazing tool for measuring distance in the vastness of space. The tool is called redshift. It happens as light between galaxies travels at a fixed speed. When the space between the galaxies expands, the light racing between them gets stretched, turning red in color.
As light goes from one galaxy to another, from a distant galaxy to our own, for example, that light gets stretched along with the stretching of space. And that causes intrinsically short wavelength light, like blue light, to gradually become long wavelength or redder light. That fundamentally is the cause of the redshift that we see in the spectra of galaxies.
How does the redshift turn into a way to measure distance? It's all because of an astonishing discovery made in 1926 at the Mount Wilson Observatory outside Los Angeles.
Being up here on Mount Wilson is always a thrill for me because it was actually right here at this location that our view of the universe entirely changed. It was here that Edwin Hubble found out the universe is expanding. And that was an amazing thing. He wasn't expecting it. Nobody thought that was the case. And it changed everything.
Seeing red shifts everywhere, Hubble found that all of the universe's galaxies were moving away from each other, which we now know is caused by the expansion of space itself. As seen from the Earth, a galaxy doesn't look like it's moving away, but we know that it is because its light is redshifted. A galaxy moving away at low speed has a slight redshift. A galaxy moving faster has a larger redshift. But Hubble found that those faster-moving galaxies are also farther away. That meant the greater the redshift, the more distant the galaxy. By seeing how fast space is expanding and working the math backwards, cosmologists have been able to estimate the age of the universe. Combine that with light speed, and you have a major brain twister.
The universe is such a huge place that the light travel time really becomes important to us. We believe the universe began about 13.5 billion years ago. That means the farthest in any direction we can look is 13.5 billion light years. There hasn't been enough time for light to travel more than that.
It's called our light horizon, a sphere 13.5 billion light years in all directions, containing everything we can see. But that's where the brain twister comes in. Does space end there?
We have no reason to believe that the distance we can see is the entire size of the universe. In fact, it might be much bigger than that. It's just that with light travel time, that's all we can see. That's our horizon.
So consider this conundrum. Astronomers in a galaxy at one edge of our horizon can't possibly see any galaxies on the other edge of our horizon. But they can see galaxies 13.5 billion light years in the other direction. And so can astronomers at the edge of their horizon, and on, perhaps to infinity. As for astronomers on Earth, light speed has them trapped.
If we ask what is happening beyond our light horizon, we have to face the fact that the speed of light really is a barrier. We've never seen anything beyond our light horizon.
Can we take comfort in the fact that there is so much to see inside our horizon? This breathtaking shot is the Hubble Space Telescope's ultra-deep field. It's a massively detailed photo of an area of the sky 100 times smaller than the full moon, yet containing 10,000 galaxies, some whose light has been speeding toward us for 13 billion years. Beyond that is the cosmic background radiation from just 400,000 years after the Big Bang. In NASA's color-coded picture, the radiation's glow is pure green, representing a distribution of matter so uniform its temperature varies no more than 1/50,000th of a degree. Nothing in human experience is even close to this kind of uniformity. In fact, astronomers believe the universe should really be very different.
By rights, the universe should be lumpy. If you look in this direction and you look in that direction, you should see two entirely different concentrations of matter, different temperatures, but it's extremely uniform. Therefore, we have a puzzle.
The puzzle has its roots at the universe's birth in the Big Bang. If everything flew apart from the beginning, why shouldn't it be uniform?
No kind of an explosion that we know of.
I'll see you guys at 12 noon Eastern today on the coming apocalypse. Give your life to Jesus Christ, because these are the prophetic signs that the Bible said would come. Earthquakes in divers places. Are you serious? Are you serious? Okay, guys. Now
The galactic core, center of the Milky Way, 26,000 years ago. And the Andromeda Galaxy, our next-door neighbor, 2.5 million years ago. But practically yesterday on a cosmic scale.
I love this cluster.
For almost 90% of the look-back time, the album is filled with common galaxies. Common, yes, but intriguingly diverse.
These two are colliding. You can see one going what appears to be right through the other. And there's a lot of drama in the way galaxies evolve and the way they interact with one another. So this one would be, well, it's only about 500 million light years away.
As Danley places